All right, welcome to the next chapter. Aren't you guys so lucky today? It is chapter 1B. So it's called 1B because it's going back to some of the linear stuff, but now instead of them being linear equations, they will be linear inequalities. All right, so what is an inequality? An inequality says that two values are not equal. And we can say A is not equal to B. So that equal sign with the line through it means not equal. There are other special symbols that show in what way things are not equal. So if I have this symbol, the alligator's biting the A, if you might remember that from elementary school, A is greater than B. If we have that greater than symbol with the line under that, that means that A is greater than or equal to. B. We can also flip that inequality so that the alligator bites the B now, and that says that A is less than B. And then again, we can have that same less than symbol with the line under it, which means A is less than or equal to B. When we solve inequalities, solutions to inequalities are represented both as a solved inequality, meaning the variable is by itself, and graphically on a number line as well. So you will have two answers. One answer is going to be the inequality, like x is greater than some number, and then a number line that goes with it. Remember, use a closed dot for a less than or equal to or a greater than or equal to symbol. Closed dots means that it can equal. And you're going to use an open dot for just less than or greater than symbols. The other big thing you want to remember, to solve an inequality, you follow the same rules as a normal equation to solve. So remember, do your order of operations backwards. The one little difference is that remember to flip the inequality symbol if you ever divide or multiply by a negative number. That's the one big difference. All right, so if we have a couple examples here, we're trying to get, in this case, the V by itself. And so if that was an equal to sign, we would try and get all the V's on the left, all the numbers on the right, and it's the same thing as what we're going to try and do now. So I have a positive 3V on the right, so I'm going to subtract 3V. And then at the same time, I want to move this 1 over to the other side because I want all the variables on the left, all the numbers on the right. So I'm going to subtract 1 from each side. So that cancels the 1's out, which is good. And I have 5V minus 3V, which is 2V. I still have my greater than symbol. And then I have negative 17 minus 1 is negative 18. To get the V totally by itself, it's 2 times V. I am dividing each side by 2. Now again, I'm dividing by a positive number, and so I am not changing my inequality symbol. It's okay that the top number is negative. That's fine. It's if I was dividing, if the bottom number was negative, then I flip. So I'm not flipping my inequality, and I get V is greater than negative 9. So that is my, what we call the inequality or the algebraic solution. And then I still have to go down here to the number line and now graph that. So when you make your number line, it doesn't have to be a crazy number line. I would usually probably put whatever this number is in the middle. And then all you really need to do is like one number to each side. So to the right of negative 9 is negative 8. And to the left of negative 9 is negative 10. And so as long as you have that number with one number on either side, your number line's good. If you want to keep going, feel free. And so remember, I do not have the equal to, and that means it's an open dot. And again, we got that from right here, open dot when it's less than or greater than. So an open dot on -9. And then I'm just trying to think about this. If I read this inequality, it says v is greater than -9. Well, which way is greater than -9? Is -8 greater than -9, or is -10 greater than -9? Well, -8 is. So all the numbers shaded to the right are going to be greater than -9. So all of these are going to be solutions. That's why we shade, because the shaded region represents the solutions. So anything in this shaded region, which would go on forever to the right, is a solution. And again, another trick, as long as your variable is on the left-hand side, which it is here, the inequality arrow will point to the way to shade. So if you kind of look, that almost looks like an arrow pointing to the right. That means our shading's to the right. And again, that's only if the variable's on the left, though. All right, one more example. Number 2 is a little tricky here. Remember, there's a negative in front of this parentheses. That's really like a -1. So I still have that 3 in front, but now I'm distributing a -1 to my two terms here. So that'd be -4m and -4. Sorry, -1. And then I have greater than or equal to 5m minus 25. Before I start moving variables around, I'm going to combine like terms. So on the left-hand side, I have like terms, 3 minus 1. Remember, when they're on the same side, you just combine them. 3 minus 1 is 2. I have -4m and a plus 2. It's greater than or equal to 5m minus 25. Now this is where we want to get all the variables on the left. And I do prefer to get the variables on the left because then our little trick here of the arrow pointing which way will work. So I'm going to subtract 5m and then subtract 2. So the 2's cancel and the 5m's cancel, which is good. So I have -4m minus 5m is -9m. Is greater than or equal to -27. We divide by -9, and I get m is greater than or equal to 3. Now, I messed up a second here because I divided by a negative. So when you divide by a negative, remember what you must do with that symbol. You have to flip it. So it's going to be m is less than or equal to 3 now. Again, that is because I divided by a negative number. So now that I have that, well, I need to just put a 3 in the middle. To the right of 3 is 4. To the left of 3 is 2. I will now have a closed dot on positive 3. And I want my m's to be less than 3. Which direction is less than? 2 is less than 3. Or again, since my variable's on the left, my arrow is pointing to the left. And so again, the shading is going to the left. So that means any number out here, -20, would be a solution. Anything in that shaded region would be a solution. All right, as we go on, we have compound inequalities now. And there's 2 types. We have OR inequalities. And to solve OR inequalities, you solve each part, then graph on a number line to show the solutions. So again, look, that's called OR inequalities because there's an OR here. And it almost looks like there's 2 separate ones, which there kind of is. It's just you graph them at the same time. So don't worry about the one on the right for now. I'm just worrying about the one on the left. So here I would subtract 4 and get 3x is less than or equal to 6. Divide by 3, and I get x is less than or equal to 2. So that's one answer. Now I don't worry about the one on the left and just focus about this one on the right. We're going to divide by 5. We get x is greater than 9. The x is by itself. So my final algebraic solution is x is less than or equal to 2 or x is greater than 9. That whole thing is my solution. Now, this is where our number line gets a little bit more intense because I do have to have both those numbers on my number line now. And I don't think I guess I do have enough spots. So I'm going to put 0 here, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that's what I have. So I have a closed dot at 2 because it's equal to. And it's saying x is less than 2. And again, since my variable's on the left, the inequality is pointing to the way I should shade, which is going to be to the left. And then I have x is greater than 9, so I have an open dot on 9. Greater than 9 would be numbers like 10, or pointing to the right. And so that's my solution. So anything in this shaded region is a solution, or in that shaded region is a solution. The reason why we have to have that word or in there is because, again, or means one or the other. My solution is either in this shaded region or that shaded region. There's not one single number that can be in both of these shaded regions at the same time. Okay, that's what the definition of or is, one or the other. All right, now we go to and probabilities next. So and inequalities, because the solutions to and inequalities fall between two endpoints, they're frequently written in a more condensed form. So there are two ways to write and inequalities. So this is one way. So 2x plus 3 is greater than -9, and 2x plus 3 is less than 30. So that's one, kind of two separate that were written the and in between. But you could also, since the 2x plus 3 is the same, you can write that in the middle. And basically you're going to write the one with the less than symbol. Okay, so I have that part. Now if you look here, the alligator's biting the 2x plus 3 in comparison to the -9, right? So when I rewrite this, here's my 2x plus 3, the alligator still be biting the 2x plus 3. And then I have the -9 as well. So I just condensed that into now one single line. Again, here the alligator's still biting the 30 in comparison to the 2x plus 3. It's still biting the 30. And here the alligator's still biting the 2x plus 3 in relation to the -9. Biting the 2x plus 3 in relation to the -9. To solve, if the and is written out, you solve each part separately. Okay, so this is where the and is written out, so it's a lot like what we just did up here. Cover up the right-hand side, solve this equation. So I'm going to subtract 1. 2w is less than or equal to 10. Divide by 2. And I get w is less than or equal to 5. Cover up the left side. I'm going to subtract 1. I get negative w is less than 20. Divide by -5. W, since I'm dividing by a negative, I have to flip my inequality. W is greater than -4. And again, the word and would be in between there. And so if we look at our number line here, here's -4, -2, 0, 2, 4, and 6. So here's 5 with a closed dot. And it says W is less than or equal to 5. So I'd be shading this way. And then here's -4 with an open dot, and it wants to be greater. So notice how the shading is in between there. So that we use the word and because any solution would satisfy both these inequalities at the same time. Sorry about that, there's your graph. So like 0, for example, is in the shaded region. It is 0 is less than or equal to 5, and at the same time, it is greater than -4. So and means it has to satisfy both at the same time, which anything in this shaded region in between these two do. If it's condensed, like this one is what we call condensed, where it's just one line, no word in between. Solve from the inside out, inside meaning right in the middle. So operations must be done to all sides of the inequality. So focus on the middle here, and it might help you just to think about, if I didn't have this, what would I do first to try and get that p by itself? Well, the first thing you do is subtract 4. But now you're subtracting 4 to all the sides. So I subtract 4 to the left, the middle, and the right. And so I'd have 4 minus 4 is 0. The 4's cancel here, so I'm left with just 3p. And then 19 minus 4 is 15. Last thing, again, I'm focusing just on that middle, trying to get that p by itself, so I divide by 3. But again, we divide all sides by 3. 0 divided by 3 is 0, less than p, less than 5. So this is saying p is in the middle of 0 and 5. So I have to have a boundary point at 0. 1, 2, 3, 4, 5. So here at 5b, I have an open dot because they're not equal, open at 0, open point at 5. And again, the shading is in the middle here because it says p is between 0 and 5. Or if you cover this up, this says p is less than 5, boop. Or alligators biting the p is greater than 0 because the alligators biting the p. All right, so that's your and an or probability. Good luck with your practice.